All right, good people, welcome back to Integration by Parts. So in the last video, we talked about this tabular method, which could be a quick way to do an antiderivative using integration by parts, as long as one of the two functions that you're multiplying differentiates down to zero, and the other one is easily anti-differentiable, right? And so for number one here, I think we can do this UV substitution, U dV, but in tabular form. If I can identify my U as X, I can take the derivative once and get 1. I can take the derivative again and I can get 0. And then I can take cosine X and I can take the antiderivative and get sine X and take the antiderivative again and get negative cosine X. And then don't forget positive, negative, positive, and we multiply diagonally. So this answer is going to be positive x times sine x, which is x sine x, plus, or I should wait, and I should multiply negative 1 times negative cosine x. Well, that is going to give me a positive cosine x, plus c. Congratulations, you just did number one fairly easily. And so it looks like this is a neat little shortcut that we can use all the time, right? I do want to warn you, kind of the same idea for number two, but now when I do my u dv here, and I do select 2x as my u because I can take the derivative and eventually get 0, when I go to do the antiderivative, I have to be very careful because the antiderivative of cosine 3x now has an inside function. So really this is like a little u substitution within the uv substitution, right? So I want to do this over here on the side just to kind of give you the big idea, and then you're going to see, oh, there's a pattern to this. So we're going to take the antiderivative of cosine 3x plus 1 dx. Well, if I do regular u substitution, my u would be the inside. That means du is 3 dx. I don't have 3 dx, but I can multiply this by 3 as long as I factor out a 1/3. And now we're able to take the antiderivative by rewriting this as the antiderivative of cosine of u. And now that I have 3 dx, I can replace that with du. Let me erase that part. Oh, the antiderivative of cosine is sine. So then this would be 1/3 sine u, except instead of u, we can just go back to the world of x's and write this here. Okay, so that gives me the antiderivative there. So can we figure out what happened here? And is there a way where I don't have to do this u substitution over and over again? Well, I noticed that so this is an inside-outside situation, right? This is a composition. The antiderivative of the outside with the inside still in it. But here, I'm multiplying not by the derivative of the inside, but by the reciprocal of the derivative of the inside. This only works if the derivative of the inside is a constant. So the derivative of the inside will be 1/3, so I'm going to multiply by 1/3. So if I try this again, my inside is 3x plus 1. The outside is sine x. So we're going to take the derivative, the antiderivative of the outside, which would be negative cosine. By the way, that 1/3 is still there. With the inside still in it, times, and now not by the derivative of the inside, but the reciprocal of the derivative of the inside. So I'm multiplying by 1/3. I was already multiplying by negative 1/3. So together, that's just going to be negative 1/9. And that's one way that I can get around doing this. All right, so I can multiply this way. Remember, we start with a positive and then it's a negative. And so then this antiderivative is going to be 2x times 1/3 sine 3x, which I'm going to write it as 2/3 x sine of 3x plus 1. And then minus 2 times minus 1/9 cosine 3x plus 2. So that's going to be plus 2/9, not 1/9. Cosine of 3x plus 1 plus c, and we're done. Okay, so I guess the understanding here is taking the antiderivative required a little bit more because we had an inside function. But if you think about it, we're always going, well, I shouldn't say we're always, but we're usually going to compensate that u and that du specifically with the reciprocal of whatever I need inside. And so we're just multiplying by 1/3 times 1/3. So if I had to do another antiderivative, which I don't because I have my answer here, but if I had to do another antiderivative, then that would be negative 1/27th the antiderivative of negative cosine is sine, negative sign. So that'd be negative sine of 3x plus 1.
Lehman High School, tutorials has now come to an end. Please start making your way out of the building. Late buses are arriving and will be leaving promptly at 5:40.
So we're going to try that with number 4, because similarly, we have a function that if I take the derivative, this is my u, if I take the derivative, I'm going to eventually get down to 0. And my du, I have this, which I can take the antiderivative, but I have an inside function, so it's going to produce a similar little u substitution situation. But if you think about what we just said, we said that if the derivative of the inside is a constant, and it is, then I can just take the derivative of the outside with the inside still in it and multiply not by the derivative, but by the reciprocal of the derivative, which would be 1/3. And if I do it again, then that would be 1/9. So it's the same idea, except a different function. I can multiply. Remember that we have to alternate signs, and therefore I can say that my antiderivative is 4x times 1/3, so that's 4/3 x. Let me do it in black here. 4/3 x e to the 3x plus 1 plus, and then multiply, that would be minus 4/9 e to the 3x plus 1 plus c, and you have your antiderivative. So far, this table method seems like it's going to be helpful, right? And the last one we'll do together here will be number 6, because number 6 now says, just take the antiderivative of the natural log of x. How do I do that? Is that even possible? There's only one function. So how am I supposed to use UV substitution? And so here is where the beauty of UV substitution comes into play. Check this out. So remember, we're choosing one function to be differentiated and one function to be anti-differentiated. Well, this is awkward because I don't know the antiderivative of the natural log of x. As a matter of fact, that's what this problem is wanting me to do. So I'm going to choose the natural log of x to be u, which means I need to put another function over here, something dx. Well, the only other thing would be to say, oh, this is 1 dx. And so now when I take the antiderivative, this would be du, that would be 1 over x dx. And when I take, I'm sorry, this is the derivative. And then when I take the antiderivative here, that would be x. Now I can say that the antiderivative of the natural log of x is multiply u times v, so that's x times the natural log of x, minus the integral of v du, Oh, but v du is going to reduce down, if I have x times 1 over x, that's going to reduce down to 1. And so my answer is x times natural log of x minus x plus c. We just found the antiderivative of the natural log of x by using this UV substitution. We now have another formula we can put into our toolbox if we ever need to find the antiderivative of the natural log of x. This would be it. Does it work? Well, if you take the derivative of this, see if it works. Take the derivative of the first times the second, minus the derivative of the second times the first, and then minus x. Do we get what we need? If we do, then we just found the antiderivative.